What's up, guys? I got another little fact-finding mission for you here, and I'm going to attempt to do this, unscripted with no edits, especially the part with no edits, so you guys can see that I'm not pulling any funny business here or doing any camera tricks or splicing together stuff. I want you guys to know that this is going to be a honest test, so I might fumble my way through it because, like I said, it's unscripted. There's no edits. So what I'm going to do on this test, and this has been quite a chore to get this one together, but what I'm going to try to do here is I'm going to test 3 identical mods made up of 3 different materials. And these are all H-Cigar Nemesis clones, copper one, brass one, stainless steel. And, before anyone says anything about clones versus the real thing, I mean, what difference does it make? It's a copper tube, it's a brass tube, it's a stainless steel tube. I'll confirm that. I'll show you guys there's no plating on these or anything like that. It's the real deal. And so what I did on this test was I built the jig. I don't know if you can see the badging on that wire, but I built the jig this time out of 18 gauge solid core oxygen-free copper wire. That's about as big as you're ever going to fit through a atomizer post. And just to show you there's no funny business, that is a positive and negative of equivalent gauge, 18 gauge oxygen-free copper. So that's how I built the test jig. I'm going to put those off to the side. There's the test jig. As you can see, that's solid core wire. Solid core wire is a way better conductor than stranded wire. You can see the stranded wire is very flexible, and that's the reason for using stranded wire. But I thought I'd do it with solid core wire this time because I think that's probably a little bit, better approximation of a resistance wire, and also it's a far better conductor because you don't have the oxygen gaps in between the individual strands of wire you would on a stranded wire. So anyhow, that being said, the atomizer deck is a Taurus, Patriot, whatever you want to call it, they're all the same. I'm not using the Dominator this time because frankly I really couldn't fit these wires through it well. And I think this is more like an industry standard kind of deck anyhow. So we've got 3 identical batteries. Those are Sony VTC3s, and they're fresh off the charger. They're all 4.2 volts. And I'll verify that on the electronic load like I did on the last test. And what I also have is a VTC4. And what I'm going to do before I use 3 different batteries, one per mod, is I'm going to use the same battery in all 3 mods because after a lot of battery testing, I really do believe there is some fact that there is a difference from cell to cell in batteries. And we could get into a lot of theory as to why, but I think pretty much the industry agrees on that, and there's a lot of testing to prove that theory. So I'm going to set these aside for right now. Now let's start off with the VTC4. And to be fair about it, obviously there's going to be some voltage drop every single time I fire one of these. But what I want to show you guys, I tried this before I shot the video just to see if I was even right or wrong, because I don't know, I've never done this exact test before. And like I said, there's obviously some voltage drop between firings, but I'm only firing it at 1 ohm, and we should see somewhere around 15 watts. And to be totally fair about it, I'm going to do it on the copper one first, because the copper one should put out, more power than the other 2. But I did this test already, and all 3 of them put out almost exactly 15 watts, even after the battery had been fired in the copper, then the brass, then the stainless steel. Down at the end of the line, the stainless steel was still 15 watts. So I think that's a big eye opener. And then I'm going to run the test with the 3 fresh batteries, obviously 3 different cells, and we'll see if that makes a big difference. I predict that it's not going to make a appreciable difference, but I could be wrong. I haven't run that specific test. So let's see what happens. So again, you guys probably remember the electronic load from last time. I won't go into how that works. If anyone's new to this and didn't see the last test, then just let me know, and I'll try to find the old one and tag you in it, and that'll give you a description of how the electronic load works. But I do have it set at 1 ohm of a constant resistance load. So again, we're not using the constant current, constant voltage, or constant power. We're using constant resistance because that simulates a heating coil pretty much as well as we can without getting real fancy with this test and doing things like ramp times and current sensing. And I don't think that there's a subjective enough difference to go through all that trouble. I think, again, just like in the last test, it's going to be really obvious. So let's start out. So there's the copper, and there's the VTC4, and there's the Taurus connected with 18 gauge solid core oxygen free copper. As you can see, there's no funny business. That's connected directly to the mains terminals, and that's just using crimped spade connectors. I tried to build a little soldered together jig out of these silver plated copper connectors, and they did fit over the binding posts, and they probably do provide a little bit more positive contact, but I wasn't really happy with the oxygen gap in the barrel there. So I think the crimp down is a much better connector for this test. And again, we're not trying to push like ridiculously high currents. I mean, maybe we'll take it down to 0.5 ohm or 0.2 or 0.3, or let's see where it goes. But I think this is good enough to get the idea. Even at 1 ohm, it's going to prove or disprove something. So let's fire it up. There's the copper, there's the battery, and I've already set the top pins so that they make the best possible contact with the atomizer. I didn't want to do that on camera. I just wanted to save some time and not bore you guys to death. So let's get on with it. Okay, so there's the battery. As you can see, no funny business there. VTC4 is the one I showed you. Putting that in the tube. Okay, no rattle. Again, no funny business. I'm not loading this test. Let's screw it onto the Addy. And I'm not going to lay it on its side like I did last time because of the camera angle. I'm just going to stand it up. I hope you guys can see that well enough. But I think you'll be able to see when I'm firing it. And when I'm not, you'll see the numbers change. So let's turn the load off. And let's verify the voltage of the battery. Okay, there we go. 4.172. So, we're verifying that that's a charged battery. And again, the load is off, so it's not draining any current from that battery. And once again, I let off, and we have that same capacitance issue that we did last time, where there's a remaining nominal voltage within the tube. And again, that's because of capacitance and inductance, but I won't go through the whole theory of that again. So let's go ahead and turn the load on, and let's see what we get. Okay, 16 watts, 15 watts, it's going down, good enough. So let's unscrew this one, turn the load off. Let's transfer the battery over to the brass tube. And again, I hate to bore you guys to death and do this all in real time, but I really don't want to do any edits because then someone might question, did I do something off camera? And I don't even want to go through all that kind of BS. Okay, so there's the copper. We're putting that away. Let's grab the brass. Again, no funny business. Pins have already been set, And these have all been freshly cleaned. So if someone wants to make the argument that, you know, oh, well, one was dirtier than another or whatever, that's just not true. They were all freshly cleaned. I polished them all. I polished the contacts, did the best I could. So we're putting the VTC4 in there. No funny business. And let's screw the Addy on. Okay, and again, I mean, look at that. We had some capacitance even before I touched anything. It's wild. So anyhow, load is off. You can see the off indicator. And again, I'm gonna try to put this out of the way of the display, but also, you know, in a position where you guys can verify that I am actually firing it. So the load is off, 0 volts, no power being drawn. Let's go ahead and make contact and complete the circuit and verify. Okay, 4.17, 4.16. Yeah, all right, the battery sagged just a little bit, but who cares? Let's turn the load on. Okay, we got an unregulated load, meaning the circuit's not complete. Let's complete the circuit. Well, I'll be damned. Look at that. 16 watts, 15 watts, exactly the same as the last one. So we'll turn the load off. We'll get this guy off of here. I'll take the battery out. Again, I'll do this in real time so you guys know there's no edits or funny business going on. Same battery. We'll put the copper tube aside and we'll move on to the stainless steel. Now, you know, to be totally fair, the stainless steel does have brass threads, but I just don't think that makes any difference. We'll see. So, same battery, Sony VTC4. I already set the top pin. This is all nice and clean. Same deal. Okay, that's nice and snug. As you can see, there is no load being presented. And again, I'll kind of keep this off to the side. And don't think the bend in the wires or anything makes any difference at all. It's just a wire. So let's verify that the battery is charged. Okay, 4.164 volts. That's obviously lower than it was in the copper and lower than it was in the brass. I mean, it would be real surprising if we got the same result, right? Well, let's see. There we have a load presented, and I'm going to complete the circuit. Well, I'll be damned. Look at that. 15.7 watts. And that's on a battery that's sagged already. So 0.3 watts difference between, you know, the copper, the brass, and the stainless steel, keeping in mind that the battery was freshly charged on the copper. I think that kind of proves that there is absolutely zero difference between the material composition of any of these mods. Well, okay, not any of these mods, at least these 3 mods. So let's move on to the next segment of the test. Turn that load off. Let's get this battery out of here. And let's put a fresh battery in each mod. And again, I'll do this all in real time so you guys know I'm not playing any funny business here. There's no tricks, no camera tricks, no edits. There's the VTC4. We're putting that aside for now. And let's take the 3 freshly charged VTC3s, and I'm going to attempt to keep these in the camera so you know that I'm not doing anything funny like switching batteries around or whatever. So there's the stainless steel, there's the copper, and there's the brass. And there's all 3 buttons. Okay, so I'm putting the VTC3 freshly charged into the stainless steel. Let's put the cap on. Okay, there's that one. Let's put one into the copper. And again, I'm just going to present the 1 ohm load, and maybe if this test runs the same way as the last one, I'll drop the load a little bit, and we can see if at higher current levels there's any difference. So I'll take it down to 0.5. And I hope you guys are able to see all of this stuff. I'm not directly in front of my computer monitor, so I'm kind of having to shuffle my eyes back and forth between what I'm doing here and the computer monitor off to my left. All right, let's start with the copper. And we'll do it in the same order: copper, brass, stainless steel. And I hope you can see the screen. I'm going to attempt to keep these off to the side so you know that I'm not putting them out of the camera's view and doing something funny. Again, there's the same torus, same leads, nothing's changed there. Let's start with the copper. Okay, so there's the copper mod. See 0 volts. The load is off. 1 ohm load. Let's just verify the battery. 4.177 volts. And I charged these on a LUC 4. I don't know if it makes any difference. I noticed the X-Star VP1 peaks the cells a little bit better. But whatever, that's splitting hairs. As you can see, same capacitance issue. So let's turn the load on. Boom, there we go. Even less. How about that? 15.6. It's floating all over the place, but let's call it 15 watts. So let's get this guy off of here. And let's set him down over here. Grab this brass one. So once again, let's just verify the load is off. One ohm, nothing's changed. Same leads, same deck. Let's verify the battery voltage. 4.23. I'll be damned, look at that. So definitely there's a difference in the quality of the cells. One peaked at 4.23. I don't think that's the charger. All of these peak chargers they're pretty accurate. They all pretty much cut off at the same voltage, and I'm pretty sure that the LUC 4 uses the same comparator for all of its bays, but I could be wrong on that. But anyhow, there we go, same capacitance issue. Let's turn the load on, and I would expect to see a higher wattage because obviously the peak on this battery is a little bit higher. Well, let's see. Nope, same damn thing. How about that? Okay, moving along. Okay, let's go to the stainless steel. And again, none of these has left the camera view. Nothing funny's happened. No edits. And wow, look at that. We still have capacitance in the Addy deck. That's something I never noticed before. The Dominator definitely didn't have that problem. And look, just by me touching it, that was enough to alleviate the capacitance. Obviously, there's a voltage in your fingertips and an inductance in your fingertips because you can measure the voltage drop across your fingertips. Anyhow, that's pretty irrelevant. So we're moving along here to the stainless steel mod. Once again, load is off, 1 ohm, nothing's changed. Let's check the voltage. 4.225. So again, we're seeing a real obvious difference in the peak voltage of these cells. And honestly, that's what every every piece of data I've ever seen and every bit of battery testing I've done over the last 15 years tells me that there's way more difference from cell to cell, even within the same make and model, than there is these metal tubes. So I think that's a really valid point. I'm glad that's showing up here, because I think when other people are doing tests, maybe they're not taking that into account. I don't mean to dog anyone out, but that's a fact. I mean, you guys can see it right there on the meter. So let's go ahead and present the load. 1 ohm again. And what do we have? I'll be damned. 14, 14.6, 14.5, 14 point whatever. It's obviously not a big enough difference to say that like one hits harder, or, I mean, if any of you guys can, tell the difference in 0.3 of a watt, hey, more power to you, but I definitely can't tell the difference. Not when you're vaping, and, you could go grab like a Hanomod or some other variable wattage device, and you could sit there and try to change things, up and down 1 watt, and I'm pretty damn sure you won't really be able to feel a repeatable difference. So anyhow, look at that. So that's the end of that test, and I don't think I'm even going to go further. I don't want to make a longer video. It's pretty late here. I want to upload this so you guys can see it, and blast me or whatever you're going to do. But if you guys want to see the exact same test run at a lower resistance, I'd be more than happy to do that. Well, you know what? I tell you what. Let's go ahead and do that real quick. Shouldn't take too much time. Let's just set the resistance to 0.5 ohm, and that'll avoid having to go through all of this again. Oops. Okay, so we'll run through this real quick. I'm not going to go through the whole spiel of the load being on or off or this or that or any theory. I mean, I think you guys get the idea now. So here we are on the copper. Let's turn the load off. And I don't really know what's going to happen here. I've never done this test this exact way, so I might be surprised. I might be wind up being totally wrong here. So there we go, 0.5 ohm, 4.168, 169 volts, whatever. And there it is again. There's that capacitance and that built-in inductance. And one of these days I'm going to do a video, and maybe I'll put up a whiteboard and I'll draw some schematics, and I'll get into some electronics engineering theory, and I'll explain to you guys exactly what capacitance is and exactly what inductance is, and why it makes a bigger difference in these mods than the batteries or the tubes or anything like that. So let's go ahead and present the load. 29, 28, whatever. Let's turn that off. Move on to the brass. And again, we can run this all the way down to 1 ohm if you want in 0.1 in 0.1 ohm increments, but I think it's just a waste of time. Maybe I'm wrong though. Tell me if you guys want to see that. So there's the brass. And there's that capacitance again. That's wild. I mean, I can't believe that it's there, even on just the deck. That really tells me how poorly designed this stuff is. No offense meant. So, let's take a look at that. 4.223. Remember, that was the battery that peaked hotter than the rest last time, and we still didn't get any real significant difference in the power. There's that damn capacitance again. So, let's turn the load on. 28. No surprise there. Turn the load off. And watch this when I pull it off. May or may not be right here, but my guess is that capacitance is still going to be there once I get rid of the mod. That's wild. I've never seen that before. Yeah, look at that. Wow. That's a revelation to me. That's a new one. I've never seen that. All right, moving on to the stainless steel. And again, bear with me here. I'm trying to do this all in one take. I might be fumbling around a little bit. It's pretty damn late, but here we go. Loads off. Let's see what the voltage is. 4.261. Looks like these are starting to level out, and that's pretty typical of these cells, because keep in mind, the manufacturer rates them at 3.7 nominal volts. And, if it happens to peak a little bit higher, I kind of think that's to be expected, because, the manufacturer is only rating them at 3.7 volts. So if they happen to be 4 or 4.1 or 4.2, well, that's exceeding the manufacturer specifications. But my guess is the differences would be even less if we let these equalize to 3.7 nominal voltage. But anyhow, I'm rambling here. So there we go. Let's turn the load on. 0.5 ohm. Look at that. 27, 26. Really, no difference. I mean, we're talking about like half a watt, 0.3 of a watt. And we're also talking about 3 batteries that have an obviously different voltage. And you saw when I did the test with the single battery, even though it was slightly discharged from each firing, it was even closer. So I don't know if that busts anyone out, but I think it definitely shows something. And again, like I said last time, if you guys see any flaws with the test, please let me know. I'm trying to do this on the best test equipment that's available. I mean, that's a pretty damn good load. This is why the inline voltmeter test isn't really a good test, because this load is buffered. And what that means is it has what's called a current shunt. And that shunt basically is a parallel off of the feed from the wires. And that shunt goes into something called a isolation amplifier. And what the isolation amplifier does is it's tuned, it's calibrated to a known reference. And so what this load does is it measures the offset in the voltage, which is way, way more accurate than trying to do an inline test, because as soon as you do an inline test, you've now added the resistance of the meter, the capacitance of the meter, the inductance of the meter. It's really just not an accurate test. Maybe I could do one of those tests down the road and then compare it with the readings on the load, and you can see just how far off it is. And, if you guys are interested, I'd be more than happy to pull the cover off the load and go through the guts of it and show you exactly how it works and exactly how the electricity flows through it and what does what and why it's so important to do the testing this way. And this is the industry standard for electronics qualification. Basically, every consumer electronic good you've ever bought that has any kind of certification on it was certified on this exact kind of device. It may not be this specific brand, but the principles are exactly the same. And this is a very, very high quality electronic load. I wouldn't attempt to do this on an inferior electronic load, because that might give you skewed results. But anyhow, that's the gist of it. I'm going to upload this. Hope you guys enjoy it. If you have any questions or comments, please feel free. If you want to scrutinize the test or question it, I always welcome that. As I said before, in the last test, we're all human and prone to error, and there might be a flaw in this test. But from where I'm sitting, it seems pretty conclusive to me. Anyhow, enjoy.